Assalamu alaikum, my name is Alhassan and I'll be presenting about the design of flat slab. So the design of slab will be done using different skills and techniques in software and manual calculations. The main aim is to come up with a design that is safe and economical. As seen here is the 3D flat slab with drop panels and edge beams. Before starting with the design, we have to analyze the minimum thickness and check for the punching shear. According to the resulted thickness, after calculations, our minimum thickness using table 21.4 of thickness with drop panels, it resulted that the thickness is 0.17 with consideration of the edge beam. Performing both safe punching shear and manual punching shear, both punching shear resulted in less than 1, which means that it's safe. Safe punching shear showed different results than the manual punching shear due to the finite element used in the software, and therefore the safe is more accurate. The design will be used different techniques. So to put hands on the design, we have to first analyze the strips, which will be divided into two main categories: short direction and long direction. For each, there will be interior column strips, interior middle strips, and exterior column strips. To analyze the exterior column strip dimension, we took 25% of the largest span and added to half the dimension, as shown here in red. This is the exterior column. This is the exterior column strip. These are the interior column strips, and these are the middle strips. We have in the long direction 4 groups. In the short direction, same approach was used. We have 5 groups. Design parameters, as shown here, the concrete compressive strength is 35 megapascal. The reinforcement steel yield is 420 megapascal. These were designed in the design. We first had to analyze each of the ISC, beta T, in long and short direction. Beta T resulted in less than 2.5. As a result, we had to use this ACI table to get the modified factors for both the X direction and the Y direction. Now, shown in the table is the full design. So basically, we used Excel in our design to simplify our approach and make it easy to design for each strip. Now, for each strip, there are 5 locations: exterior negative, positive, first interior negative, positive, interior negative. We then multiplied the M node by each of the modified factors to get the column strip moment. Then we analyzed the Rn using the formula, reinforcement ratio. For the reinforcement ratio, if it's less than 0.0018, we had to use a function in Excel. Then we got the reinforcement area, and then the reinforcement area per meter. It resulted that in the negative, a top steel of 3,516, for the positive, bottom steel of 4,516. For the first interior, 6,516, 3,516, 6,516. This is the detailing. For the detailing, we used AutoCAD for detailing of flat slab. Shown on the detailing are the bar number of steel and each location and length. Also, spacing is shown at each location. We also used a steel web of 3,516 top and bottom steel along short and long directions. Now, after designing the flat slab, we'll be designing the columns associated with the flat slab. Due to the large amount of columns, we divided the columns into 2 major groups. One, which is the groups from the ground floor, first floor, second floor. Group 2 is third floor and fourth floor. For each group, there are 5 minor groups: corner column, long edge, short edge, middle column, and middle column 2. Middle column 1 and middle column 2. After analyzing the loads of the columns by using the safe software as shown here, we took these loads and we checked the slenderness ratio. We also calculated, these columns are tight columns, so we also made assumption about the rho G, the percentage of steel reinforcement. The FC prime was 335 megapascal, and then we calculated the area gross. After calculating the area gross, we square rooted the area gross to get the dimension of the column, then the area of steel, AST. Then we used table B.2 to select the steel. Then we designed for the ties. As shown here is the detailing. Group 1, reinforcement, long edge of 6,513 with 10 ties at 200 millimeter of long edge and short edge. For Group 2 reinforcement, long edge and short edge shows that 4,510 with 510 ties at 150 millimeter. As shown here, these are the detailings with the same dimensions. Dimensions was noticed to be the same according to the calculations. And now I'll leave you with my friend Mustafa Abdullah to explain the design of flat plate.